For escape and survival from supersonic airplanes, anything short of total encapsulation is only a halfway measure. But even supersonic airplanes can have accidents at slow speeds. Any escape system which fumbles the low-speed escape problem is even worse than half-hearted. It's unforgivable. Reliable escape from a disabled plane stationary on the runway is no longer tomorrow's goal. It is here today. Whether your escape problem lies in the high supersonic or the extreme low speed end of the spectrum, there is no company more competent in helping you solve that problem than the Stanley Aviation Corporation, America's most experienced designer and builder of escape capsules and ejection seats for jet airplanes. In response to recent emphasis on improvement in escape capability at zero speed and altitude, Stanley has evolved a truly revolutionary method of escape that uses neither an ejection seat nor a capsule, but pulls out just the man and his parachute, and does it straight as an arrow at speeds below those at which conventional ejection seats go sour. Conventional ejection seats work quite acceptably at the in-flight speeds of most subsonic airplanes, but they're basically unstable at low speed due to the fact that the push from their rockets cannot be applied positively through the man's center of gravity. At zero speed, they invariably tumble, gain little altitude, and frequently wrap up in parachute lines with fatal results. The Yankee system sidesteps such problems entirely. Its spinning rocket pulls the man straight as an arrow, regardless of his weight or the junk that he carries with him. By folding the seat, the man's limbs straighten as he's pulled by the extraction rocket, and he can go through a very narrow exit opening far smaller than needed for an ejection seat. If you let the seat move just far enough to guide him through the hatch, he doesn't scrape. If you leave the seat in the airplane, it can be light and simple. If all you have to extract is the man and his parachute, you don't need a big rocket. It's light, it's compact, it's reliable. When the man decides to go, everything is automatic from the moment he pulls the extraction control handle located between his legs. The canopy is instantly removed, even though through the canopy escape is quite feasible. A fraction of a second later, the rocket is launched to line stretch. It ignites and starts pulling the man and his seat upward. His inertial restraint is locked. The seat is free to move. The seat bottom folds. His legs and arms straighten out, and as soon as he has moved sufficiently into the middle of the exit opening, positive mechanical linkages release his harness from the seat, and he continues on in free flight. An emergency release handle frees the man from the seat and the rocket when he has to get out in a hurry. The rocket is produced jointly by Tally Industries and Stanley Aviation, and like all other ballistic items used in Yankee, has been exhaustively tested and fully qualified to Air Force and Navy standards. Some airplanes are so limited in space that the rocket must be stowed lying flat, then erected to its launch position. The optimum angle of launch can be selected by the erector to match the speed of the airplane. To test the high-speed performance of the Yankee escape system under laboratory conditions, an A-1E airplane was converted into a rocket-propelled sled, fully equipped with two side-by-side Yankee escape systems, capable of being fired either simultaneously or in random sequence. Anthropomorphic dummies representing men of various weights were equipped with automatic recording instrumentation to measure physiological forces. In the A-1E installation, the rockets were located behind the seats and aimed away from center line, so that even though two men were to escape simultaneously, their paths would diverge with no risk of collision. Dozens of 0-0 tests conducted at the Stanley Test Range near Denver, Colorado, perfected and refined the reliability of zero-speed escape from ground level. To verify high-speed performance of the Yankee escape system, a lengthy series of sled tests were performed at the Stanley-owned supersonic test track located on top of the cliffs at Hurricane Mesa, Utah. This unique facility is the only privately owned test track in the world. Its private ownership has permitted steady testing progress, unhampered by conflicts relating to defense priorities. Photographic coverage and telemetry recording capabilities permit precise determination of performance characteristics, even under conditions of simultaneous multiple escape extractions. Rocket ignition occurs at line stretch, and hence the rocket flame is never near the man. This permits random sequencing of escape as shown by the simultaneous extraction of two dummies sitting side by side. The rocket nozzles are skewed slightly to impart a spinning action to the rocket to enhance stability and to minimize the hazard of having its jet aimed steadily in a given direction. When the rocket has expended 95% of its energy, it automatically disconnects from the man and its remaining power propels it away. Immediately thereafter, the tow line disconnects from the man and he's in free flight. Shortly thereafter, the parachute is automatically opened by conventional means. The rocket can be located at any convenient place in the vicinity of the man and can be aimed to maximize his separation from other crew members. Notice that the pilot and co-pilot have been aimed to land on opposite sides of the test track, well separated from each other and from the sled. On February 17, 1966, Harry Schmall, Vice President of Parasystems, became the first human to be extracted from an aircraft in flight by the Yankee escape system. His subjective reaction, as verified by instruments, was that the extraction from the airplane was somewhat less than parachute opening shock. The Yankee escape system is operational for the A-1E and is now being fitted for the Navy A-1HJ. The installation in this airplane is similar, with the exception of the survival and parachute pack being carried in the seat rather than the back. Also in this installation, the rocket is mounted beneath the canopy in a horizontal attitude. Upon extraction, it is raised into position by an erector. The parachute back and back frame with seat pack chutes incorporate a headrest for support during extraction and naval catapult loads. The Yankee escape system is an off-the-shelf item which is adaptable to most subsonic aircraft. Because of its unique operation, it can be installed in cockpits which have a small egress opening and which will not accept a conventional ejection seat. So far, so good. But how about escape from a wildly gyrating airplane in distress? Will the tow line wrap around the airplane or collide with its tail surfaces? Will the man exit cleanly when pulled by a tow line that may be pulling at a crazy angle? Computer studies give answers, but you really never know how much you can believe them. They are only as accurate as the inputs you feed into them. The only real answers, which nobody can challenge, is to equip an airplane with the Yankee escape system, then actually go up and find out. In collaboration with the U.S. Navy, a rugged acrobatic airplane was tested doing dives, slow rolls, cartwheels, snap rolls, and spins at rates exceeding 170 degrees per second. In all cases, tail clearance was excellent. Separation of the dummy from the airplane was clean, with no scraping, no dragging, no sign of injury. The Yankee escape system uses the U.S. Air Force or Navy restraint garment. The extraction rocket thrust is applied to the man through the restraint garment in exactly the way parachute loads are applied. The maximum thrust is less than 2,000 pounds for a half second, giving an acceleration of less than 12 Gs, well below the accepted tolerance level for plateau accelerations for such short durations. No other escape system has ever been subjected to such grueling and hazardous testing. From these spectacular trials have emerged further refinements and safety improvements, which recommend the Yankee system for reliable escape from any subsonic airplane, old or new. Truly, a product of Yankee ingenuity.